Just go through it step by step. First, identify the GCF of the coefficients 18, -27, and -45. The GCF of these three numbers is 9. Now let's check the variable factors of each term. All three terms have at least a to the first power, so a is part of the GCF. Now look at the b's. We have b to the second power, b to the third power, and b to the second power again. All of the terms have at least b to the second power, so b to the second power is part of the GCF. Finally, look at the c's. We have c to the factoring means rewriting an expression as a product. For part A, we want to factor 21a minus 7b. We want to rewrite this difference as a product. First, look for the greatest common factor, or GCF, of the two terms. The GCF may be a number, a variable, or a product of both. Notice that 21a is divisible by 7, and 7b is divisible by 7. The GCF is 7. Now divide each term of the original expression by 7 to find the other factor. 21a divided by 7 is 3a. Minus 7b divided by 7 is minus b. So 21a minus 7b equals 7 times the difference of 3a and b. Notice that factoring is like using the distributive property in reverse. In fact, we can use the distributive property to check our factoring. 7 times 3a is 21a, and 7 times negative b is negative 7b, the original expression, so our factoring is correct. For part b, we want to factor 12a squared plus 16ab squared minus 12a squared b. First, identify the GCF of the coefficients, 12, 16, and negative 12. The GCF of the coefficients is 4. Now identify the GCF of the variables, a squared, ab squared, and a squared b. Since each term has a factor of a, the GCF of the variables is a. The GCF is 4a. Now divide each term of the original expression by 4a to find the other factor. 12a squared divided by 4a is 3a. 16ab squared divided by 4a is 4b squared. Negative 12a squared b divided by 4a is negative 3ab. Again, if we wanted, we could check our work by multiplying. Now let's factor the expression in part C. It looks intimidating, but just go through it step by step. First, identify the GCF of the coefficients 18, -27, and -45. The GCF of these three numbers is 9. Now let's check the variable factors of each term. All three terms have at least a to the first power, so a is part of the GCF. Now look at the b's. We have b to the second power, b to the third power, and b to the second power again. All of the terms have at least b to the second power, so b to the second power is part of the GCF. Finally, look at the c's. We have c to the second power, and c to the second power again. Since all three terms have at least c, we'll include c in the GCF. The GCF is 9ab squared c. Now divide each term of the original expression by 9ab squared c to find the other factor. 18a cubed b squared c divided by 9ab squared c is 2a squared. Negative 27ab cubed c squared divided by 9ab squared c is negative 3bc. Negative 45a squared b squared c squared divided by 9ab squared c is negative 5ac. The expression is factored completely. In this expression, the first term is 3 times the sum of a and b. The second term is x times the sum of a and b. Notice that each term has the common factor a plus b. Write the common factor a plus b, and divide each term by a plus b to find the other factor. 3 times a plus b divided by a plus b is 3. And x times a plus b divided by a plus b is x. The expression is now completely factored. We're going to factor some expressions.